Okay, guys, so if you are getting this video, it means you're absent for Thursday, January 27th. And so we are going to, instead of starting to look at the star cycle like we originally planned, we're going to continue on this understanding atoms and elements and how the numbers connect to the atom. The numbers on the periodic table connect to the atom. So just quick review. So what we learned yesterday was the type of atom is determined by the number of protons. Okay, and we identify that with the atomic number, and that's always the smaller number on our periodic table. Should only see about two numbers on most charts. Some of them have way too much information, but the smaller number of the two is going to be your atomic number, and that tells us how many protons we have. Okay, then the atomic mass. We're saying, okay, how much mass does this atom have? And all the mass is basically made up by the nucleus, and we know the nucleus is protons and neutrons. So the atomic mass is just the number that tells us how many protons we have plus how many neutrons we have. Okay, and then finally the charge of the atom. So when we're looking at the periodic table, we can just assume, unless we're told otherwise, that they are neutral atoms. So in a neutral atom, we have the same number of protons and electrons. But that's not always how these atoms exist. So if we ever ask to find the charge, we just take the protons and we subtract the number of electrons. Okay, and that's going to tell us whether it's a positive or negative charge. Okay, so now our goal today is we want to be able to do exactly that. We want to be able to look at the periodic table, look at any element or type of atom, and be able to identify how many protons it has, how many neutrons it has, and how many electrons it has. Okay, so to do that, we need to understand what those element cards on the periodic table are actually showing us. So, real quick, pause the video, and I want you to draw this exact thing in your notes. Okay, so with the atom model, what we did yesterday, right? We used that simulation. We built atoms. We added protons, neutrons, electrons, all that stuff. So our atomic model is something like this. This is what we think about when we think about an atom. Well, the periodic table has these symbols. So the symbol represents each element. It's always a capital letter, and then it might have a lowercase letter after it. Has the element name sometimes, and then it has these two numbers, right? And so, like I said earlier, the smaller number, right? So 1 is smaller than 1.008. That's going to be the atomic number. That tells us the number of protons. Okay, so that's telling us how many protons are. And we can see that in this model here. We only have one proton. Okay, now our atomic mass, the larger number, is going to be our protons plus our neutrons. And we can see we have one proton, 0 neutrons. So 1 plus 0 is 1. That's why this is pretty close to 1. Now, one question that gets brought up is why are these decimals? There are alternate forms of hydrogen. Some hydrogen has a neutron, surprisingly. So that brings the average of all the hydrogen we know of, brings that average up just a little bit. Okay, so that's all these element cards are doing. So another example of this is with helium, and we can really start to see how this nucleus ties into this atomic mass. Okay, so again, atomic number is just identifying how many positive protons we have. So in this case, we have 2, right? And then down here, we can see 4. So we can literally count these up. We have 1, 2 positive protons, and then we have 2 neutrons. So 2 plus 2 is 4. That's where we get this atomic mass. Okay, so that's really all these element cards are telling us, is just saying, okay, this is our atomic number that identifies which element it is and how many protons. And then the total mass, protons and neutrons, is this number down here. Okay, so it becomes really easy to see, okay, what does this atom start to look like? Okay, and we can see again here. So with one of these, let's make sure we have at least 2 of those drawn in our notebook, especially with either lithium or helium, so we can see that difference. Okay, now what we did then is you guys can go back to the atom builder, and what we want to see is, okay, let's build this neutral atom of lithium. Okay, so we'll just kind of go through this together. Okay, so here's lithium. It's not neutral, and it's not, there we go, good. Okay, we have this neutral atom of lithium. Okay, so then the directions say, and I want us to keep an eye over here, it says, okay, take away one of those electrons. What word pops up? It says positive ion. Okay, so let's think about this. What this is showing us here is we have 3 positive protons, right? We see that up here. And we only have 2 negative electrons. Okay, so we can see we have one more proton than we do electrons. That's what gives us a positive charge. And all that means is when we see the word ion, is that that atom now overall has a net charge. It's either positive or negative. Okay, and we can do it the other way too, right? So if we add in an extra electron, now it becomes a negative ion. And all that means, guys, is just we have one more negatively charged electron than we do protons. These ones cancel each other out. And if they are balanced, right, it's neutral, gain or lose one, we become positive or negative, right? So let's make sure that we add that into our notes. Now, it's really important to understand that this is the gain or the loss of only electrons, right? Because if we change the number of protons, we're changing what atom we have, and we don't do that, right? So we can either gain or lose electrons. And when does this happen? This happens when atoms bond. So some of these electrons get pulled away by other atoms, okay? And we'll get to that later, but the big thing to understand is we can only change the number of electrons. We can add more to it, or we can take some from it, okay? Now, where we see this, right, again, so a positive ion has lost an electron. So if we see like H plus, this is showing that it has a net positive charge, which means it lost one electron. If we see 2 plus, same thing, right? It has a positive 2 charge, which just means it lost 2 electrons. Okay, it has the same number of protons as it started out with. We've just lost 2 of the electrons. And then just opposite of that, negative ions, right? So oxygen here, since it's negative 2, means it has 2 more of these negative electrons, giving it overall a negative 2 charge. Same thing with fluorine, okay? So it's the only tricky thing with this is we are gaining and losing a negative, which is, we know in math, that's hard to kind of wrap our head around sometimes. So it's kind of backwards, but we just want to think of it as a charge, right? So we have one more negative charge or one more electron, 2 more electrons, okay? And then last thing we wanted to talk about was this word comes up, isotope. And an isotope, all that is just a different version of the same atom. So we can see here with carbon-12, this is the most common carbon that we have. We have 6 protons, and we have 6 neutrons, giving it a total mass of 12. Okay, but there's also the version of carbon where we still have 6 protons, right? That's what makes it carbon. But we have 2 extra neutrons, right? Giving us a total of 8 neutrons, making our mass 14. So it's still a carbon atom. It's just a different version. And the only thing that's different is it has a different number of neutrons. We're not going to get too much into isotopes. They do behave a little bit differently, but when you see the word isotope, it's just a different version of the same atom. Okay? Now, this is probably the biggest piece, because what you're going to be asked to do on tests, things like that, is we're going to give you an element card, like one of these. Okay? And we're going to ask you things like, how many protons does it have? How many neutrons does it have? How many electrons does it have? Okay, and so if we follow these steps right here, it's pretty straightforward, right? So if we say, okay, you need to find the number of protons, well, that's just the atomic number, and then you're done. Okay, neutrons. Okay, so we take the atomic mass, which is the bigger number, and we just subtract the atomic number. Boom, done, right? And that is it's as simple as that. Okay, and that tells you how many neutrons. So if we write these down, guys, and just follow these steps, super easy. Now, electrons, whoa, 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 whoa. Electrons, it's a little bit different, right? Because again, when we're talking about ions here, so in this case, we'd say, oh, you have a lithium ion. Okay, find how many electrons does it have? Well, okay, first thing is if it's not an ion, if it's a neutral atom, and we're trying to find how many electrons, it's easy. It's the atomic number because we have the same protons as electrons. It's balanced. It's neutral. Okay. If your ion is positive, so say it says lithium +1, all we do is we take that atomic number, which would be 3 for lithium, and we subtract whatever our positive ion is, whatever charge we had. So +1. So 3 minus 1 equals 2, meaning we have one more proton than electron. And then just the opposite for negative ions, okay? So if you write these down and you just follow those steps, like literally plug in your atomic number, plug in the number of charge here, you'll get it right every single time, okay? And then the last thing that we did this is kind of our assignment that you'll see on Google Classroom. So all you're doing here is you're looking at the periodic table, and each of them have symbols, right? These letters, so like H. And you guys are just going to come up with some word or phrase. Somebody spelled rhino, right? Only using those symbols. So you have to, all the symbols must include the atomic number and atomic mass when you write them. So just meaning it needs to look like this, okay? Then, of your symbols, at least 3 of them, you have to show how many protons, neutrons, and electrons it has. So just like we talked about here, right? So if we said, oh, here's carbon, I would say, okay, I have 6 protons, and I did 12 minus 6, so I have 6 neutrons, and it's neutral, so I have 6 electrons. So you're just writing that down next to the element, okay? And then finally, of these 3 that you solve that for, you have to say one of them is a positive ion or a negative ion, right? One of them has to be an ion, and you're going to show me what that means, right? By the number of electrons you have. You're either going to have more electrons than your protons or less, okay? And then when you're all done, just take a picture of your word and turn it into Google Classroom under the assignment that should say periodic table phrase assignment. All right, let me know if you guys have any questions. Bye.